Welcome to Chapter 4 of our course on machine intelligence, from Turing Test to large language models. In this chapter, we will embark on an insightful journey into the realm of creativity and novelty within artificial intelligence. I am excited to guide you through this fascinating topic. As AI continues to evolve, understanding how creativity can be quantified becomes increasingly important. We'll explore how machines can not only mimic human creativity but also generate novel ideas, products, and solutions that have tangible value. This chapter aims to shed light on the metrics and methodologies used to assess and enhance creative outputs in AI systems. The quest to define and measure creativity in AI is both challenging and intriguing. Traditional notions of creativity involve subjective judgments, making it difficult to establish standardized evaluation criteria. Throughout this chapter, we'll delve into how we can bridge this gap by combining objective metrics with human perceptions to create a comprehensive understanding of AI creativity. We'll examine the nuances of divergent thinking and how it applies to machine intelligence, exploring concepts such as fluency, flexibility, and originality. Moreover, we'll discuss techniques for detecting novelty in AI-generated content, which is crucial for fostering innovation and preventing redundancy. Novelty detection not only helps in evaluating the uniqueness of AI outputs, but also plays a significant role in various applications across different industries. By the end of this chapter, you'll have a deeper appreciation of the complexities involved in quantifying creativity and the potential it holds for advancing AI capabilities. So, let's dive into the world of AI creativity, where we'll uncover the methodologies and challenges associated with measuring and enhancing the creative prowess of machines. This exploration will not only enrich our understanding of AI, but also open up new possibilities for integrating creative AI solutions into various aspects of society. In this chapter, we'll be focusing on three main areas that are pivotal in quantifying creativity and novelty in AI. First, we'll examine metrics for creative outputs, where we'll attempt to define creativity within the context of artificial intelligence. This includes discussing the importance of both objective and subjective metrics in evaluating AI-generated content. Understanding how to measure creativity is essential for developing AI systems that can produce valuable and innovative outputs. Next, we'll delve into divergent thinking measures. Divergent thinking is a cornerstone of human creativity, involving the generation of multiple, diverse solutions to a single problem. We'll explore how this concept translates to AI and the mechanisms through which we can assess an AI system's capacity for divergent thinking. We'll look at components such as fluency, flexibility, and originality, and how they contribute to creative potential. Finally, we'll discuss novelty detection in generated content. Detecting novelty is crucial for identifying unique and valuable ideas while filtering out redundancy. We'll explore the techniques used for novelty detection, the challenges involved, and the various applications where it plays a critical role. This includes fields like text generation, art and design, and scientific discovery, where innovation is highly prized. By the end of this chapter, you'll have a comprehensive understanding of how creativity and novelty are quantified in AI, the challenges that arise in this endeavor, and the future directions that research in this area might take. Creativity, at its core, involves producing novel and valuable ideas, products, or solutions that are both original and useful. In the context of artificial intelligence, this translates to the ability of machines to generate unique text, art, music, or to solve problems in innovative ways that have not been explicitly programmed by humans. Defining creativity in AI is inherently challenging due to the subjective nature of creativity itself. What one person considers creative, another might not, as cultural, societal, and personal preferences heavily influence these judgments. One of the main challenges in defining AI creativity is balancing novelty with usefulness. An idea that is entirely novel but not useful might not be considered truly creative. Conversely, An idea that is useful but lacks originality may also fall short of the creative mark. Therefore, in quantifying creativity, we must consider both the uniqueness of the output and its value or relevance to a particular context or problem. To address these challenges, we utilize both objective and subjective metrics. Objective metrics involve quantifiable measures based on data, such as statistical rarity or diversity indices. These metrics provide a way to assess creativity by analyzing the output in comparison to existing data or known benchmarks. Subjective metrics, on the other hand, rely on human judgments and perceptions. They involve evaluations by individuals or groups who assess the creativity of the AI's output based on criteria like novelty, usefulness, and aesthetic appeal. By integrating both objective and subjective measures, we can develop a more holistic understanding of AI creativity. This combined approach acknowledges the quantifiable aspects of creativity while also capturing the nuances that come from human perception. It's important to strike a balance between these metrics to ensure that AI-generated outputs are not only statistically unique but also meaningful and valuable to human users. Objective metrics provide a quantifiable way to assess creativity in AI outputs. One such metric is statistical rarity, which evaluates how uncommon an output is compared to existing data. This involves techniques like frequency analysis, where the occurrence of certain patterns or elements in the AI's output is compared to their prevalence in existing datasets. An output that contains rare or unique combinations of elements may be considered more creative from a statistical standpoint. Another important metric is diversity, which measures the range of different ideas or solutions generated by the AI. Diversity indicates the AI's ability to explore various possibilities rather than producing repetitive or homogenized outputs. Techniques to assess diversity include entropy calculations, which measure the randomness or unpredictability of the output, and analyzing the coverage of different categories or themes within the generated content. Originality is also a key objective metric, assessing the uniqueness of the AI's output. This can be measured using techniques like n-gram analysis for text, which identifies uncommon sequences of words or phrases not typically found in existing literature. Additionally, semantic similarity measures can be used, leveraging embeddings to determine how different the AI's output is from existing data in terms of meaning and context. Higher originality scores suggest that the AI is generating content that is not only unique but also potentially innovative. By utilizing these objective metrics, we can systematically evaluate the creative aspects of AI-generated content. However, it's important to remember that these metrics primarily focus on quantitative aspects of creativity and may not fully capture the qualitative nuances that humans perceive. Subjective metrics involve human judgments and perceptions to evaluate creativity, acknowledging that creativity is often a personal and culturally influenced concept. Human judgments are central to this approach, where individuals rate the creativity of AI-generated outputs based on criteria such as novelty, usefulness, and aesthetic appeal. This can be conducted through surveys or rating scales, where participants provide their assessments, allowing researchers to gather qualitative data on how the outputs are perceived. Engaging expert reviews is another critical method, especially in specialized domains like art, literature, or music. Specialists with deep knowledge and experience provide in-depth evaluations of the AI's outputs, offering insights into the creative merit and potential impact within the field. Their expertise helps in assessing aspects that might not be evident to the general public. Crowdsourcing is also used to gather assessments from a large and diverse group of people, leveraging platforms like Amazon Mechanical Turk. This approach benefits from diverse perspectives and can achieve statistical significance due to the larger sample size. However, it also introduces challenges, such as variability in human judgments and potential biases. Subjective metrics capture the richness of human perceptions but come with their own set of challenges. Variability in individual judgments, cultural differences, and personal preferences can lead to inconsistent evaluations. Additionally, What is considered creative in one culture or context may not be seen the same way in another. Despite these challenges, subjective metrics are essential for understanding how AI-generated content resonates with human audiences. Divergent thinking is a key component of creativity, involving the ability to generate multiple, diverse solutions to a problem. It contrasts with convergent thinking, which focuses on finding a single, correct solution. In the context of AI, divergent thinking assesses the system's capacity to explore a wide range of possibilities and think outside conventional pathways. Key elements of divergent thinking include fluency, which refers to the quantity of ideas produced. An AI system with high fluency can generate numerous responses or solutions, indicating prolific idea generation. Flexibility involves the variety of categories or approaches represented in the ideas. This measures the AI's ability to shift perspectives and consider different angles or domains when generating solutions. Originality assesses the uniqueness and novelty of the ideas, highlighting how uncommon or innovative the responses are compared to typical outputs. Evaluating divergent thinking in AI is essential for gauging creative potential. It moves beyond assessing whether an AI can provide correct answers to understanding how expansively it can think and generate ideas. This evaluation helps in developing AI systems that can assist in creative tasks, problem-solving, and innovation by mimicking some aspects of human creative processes. When evaluating divergent thinking in AI, fluency is measured by the number of ideas the system generates in response to a prompt. For example, an AI might be tasked with generating as many uses for a paperclip as possible. A high number of generated ideas indicates strong fluency, demonstrating that the AI can produce a wealth of possibilities without being confined to a narrow set. Flexibility is assessed by examining the variety of categories or domains represented in the AI's ideas. Continuing with the paperclip example, ideas that span different contexts, such as household uses, medical applications, or industrial purposes, indicate that the AI can shift its thinking and consider multiple perspectives. This versatility is crucial for creative problem-solving and innovation. Originality evaluates the novelty of the ideas produced. Techniques for assessing originality include comparing the AI's ideas to known datasets to determine how uncommon they are. Scoring may be based on the rarity of each idea, with higher originality scores reflecting more innovative thinking. This aspect is important for identifying truly creative outputs that offer new insights or solutions. Combining these elements provides a comprehensive evaluation of the AI's divergent thinking capabilities. It helps in identifying strengths and areas for improvement, guiding the development of AI systems that can better emulate human creativity. Various methods are employed to test divergent thinking in AI. One such method is adapting the Turing tests of creative thinking (TTCT), originally developed for humans. These tests involve open-ended prompts and assess fluency, flexibility, originality, and elaboration. By presenting AI systems with similar tasks, researchers can measure their responses against established creativity benchmarks. Another approach is through creative problem-solving tasks, where the AI is presented with ill-defined problems that require innovative solutions. For example, the AI might be asked to design a new product to solve a common issue or develop strategies for a fictional scenario. These tasks assess the AI's ability to generate unique solutions without predefined pathways. Story generation and artistic creation are also used to evaluate divergent thinking. The AI is prompted to generate multiple narratives or artworks based on certain themes or parameters. The outputs are then evaluated for diversity and originality, providing insights into the AI's creative breadth. Evaluation methods for these tasks include both quantitative measures, such as the number of ideas generated, and qualitative assessments by human judges. Combining these approaches offers a nuanced understanding of the AI's divergent thinking abilities. Novelty detection is crucial for identifying unique and innovative outputs in AI-generated content. One set of techniques involves statistical methods. N-gram analysis is used in text generation to identify uncommon sequences of words or phrases. By comparing these sequences to existing data, we can assess how novel the AI's output is. Lower overlap with known data indicates higher novelty. Entropy measures are another statistical approach. Higher entropy values suggest that the content is more unpredictable and, therefore, potentially more novel. This method assesses the randomness in the AI's output, which can be indicative of creative exploration. Similarity metrics involve measuring the dissimilarity between the AI's output and existing content. Techniques like cosine similarity or the Jacquard index quantify how different the new content is from known data. These metrics help in identifying outputs that are truly unique rather than variations of existing ideas. Machine learning approaches also play a significant role in novelty detection. Autoencoders, for example, can be used to detect deviations from known patterns. By training on existing data, the autoencoder learns to reconstruct typical inputs. Larger reconstruction errors when processing new outputs may indicate novelty. Generative adversarial networks, GANs, utilize a discriminator component that identifies whether content is original or generated by the model. This dynamic helps in refining the generation of novel outputs. Embedding space analysis examines the position of new content in relation to existing data within an embedding space. Content that lies further from known data points is considered more novel. These techniques provide quantitative measures of novelty, aiding in filtering and promoting creative outputs in AI systems. Despite the effectiveness of various techniques, novelty detection faces significant challenges. One major issue is defining appropriate baselines. For meaningful comparisons, we need representative datasets that capture the full scope of existing content. However, it can be difficult to assemble comprehensive datasets, especially in rapidly evolving fields or creative domains with vast and diverse content. The subjectivity of novelty also presents a challenge. Novelty perception varies among individuals due to cultural, contextual, and personal factors. What is considered novel in one culture or context may not be seen the same way in another. This variability makes it difficult to establish universal standards for novelty detection. Balancing novelty with coherence is another critical concern. Outputs that are highly novel may lack relevance or coherence, rendering them impractical or meaningless. It's essential to ensure that AI-generated content maintains meaning and usefulness while striving for innovation. Computational complexity poses practical challenges. Advanced techniques like GANs and deep learning models require significant computational resources. Scaling these methods to large datasets or real-time applications can be resource-intensive and may not be feasible in all settings. To mitigate these challenges, combining objective metrics with human evaluations can provide a more balanced assessment of novelty. Iterative refinement and validation of techniques, along with careful dataset selection, can enhance the effectiveness of novelty detection in AI. Novelty detection and creativity quantification have significant applications in text generation. In creative writing and poetry, AI can enhance originality in literature by generating unique metaphors, themes, and narratives. This can assist authors in overcoming writer's block or inspire new literary works by providing fresh ideas and perspectives. In content creation for marketing, AI-generated text can produce fresh and engaging advertisements or promotional materials. By avoiding repetition and introducing novel concepts, brands can capture audience interest more effectively. AI can help in tailoring messages to different demographics, enhancing personalization. For dialogue systems, such as chatbots and virtual assistants, generating varied and interesting responses improves user experience. Novelty ensures that interactions remain engaging and prevents conversations from becoming monotonous. This can lead to increased user satisfaction and more natural interactions. In academic and technical writing, AI can assist in idea generation for research papers or projects. It can help identify unique angles or hypotheses, fostering innovation in academic work. Additionally, novelty detection is crucial for detecting plagiarism and ensuring originality in scholarly content, maintaining the integrity of academic publications. In the realm of art and design, AI's creative capabilities are opening new frontiers. AI-generated artworks involve creating unique paintings, sculptures, and installations. These works can be exhibited in galleries, showcasing AI creativity and sparking discussions about the intersection of art and technology. AI artists like Aiken have produced pieces that have sold at prestigious auctions, indicating a growing acceptance of AI in the art world. In graphic design, AI assists in generating novel logos, layouts, and visual concepts. This can expedite the design process and provide designers with a wealth of options to choose from or iterate upon. AI can help in brainstorming sessions, offering unconventional ideas that might not emerge through traditional methods. Fashion design benefits from AI by producing innovative clothing patterns and styles. AI can analyze trends, predict future fashions, and inspire new designs that push the boundaries of traditional aesthetics. This can lead to the creation of unique apparel that sets new trends in the industry. In architecture, AI aids in conceptualizing unique building designs. By exploring unconventional structural possibilities, architects can envision and develop structures that are both aesthetically pleasing and functionally innovative. AI can assist in simulating environmental impacts and optimizing designs for sustainability. AI's ability to generate novel ideas has profound implications for scientific discovery. In hypothesis generation, AI can propose new hypotheses for testing, accelerating the pace of research. By analyzing vast amounts of data, AI can identify patterns and correlations that might elude human researchers, suggesting unexplored avenues of inquiry. In drug discovery, AI aids in identifying new molecular structures and compounds. By predicting how different molecules might interact with biological targets, AI can significantly shorten the development cycle for new medications. This accelerates the process of bringing effective treatments to market, potentially saving lives. Material science leverages AI to discover new materials with unique properties. AI can simulate and predict the behavior of materials under various conditions, assisting in the development of substances that enhance performance in industries like aerospace, electronics, and renewable energy. In addressing environmental solutions, AI generates innovative ideas for sustainability. This includes developing strategies to combat climate change, reduce pollution, and promote biodiversity. AI can help model complex environmental systems and propose solutions that are both effective and feasible. Quantifying creativity and novelty in AI is a multifaceted endeavor that integrates both objective and subjective measures. By evaluating components such as fluency, flexibility, and originality, we gain insights into the AI's capacity for creative thought. Novelty detection techniques are essential for identifying unique outputs and fostering innovation within AI systems. However, challenges persist, including balancing novelty with coherence and addressing the subjectivity inherent in human judgments of creativity. It's important to continue refining our evaluation methods, combining quantitative metrics with qualitative assessments to capture the full spectrum of creativity. The applications of quantifying creativity and novelty are vast, spanning text generation, art and design, and scientific discovery. These advancements have the potential to revolutionize industries, contribute to cultural evolution, and address some of the world's most pressing challenges. Developing robust metrics and methodologies is essential for advancing AI's creative capabilities. As we continue to explore this frontier, the collaboration between AI and human creativity holds promise for unlocking new possibilities and enriching our understanding of intelligence. Looking ahead, there are several key areas for future development in quantifying creativity and novelty in AI. Integration of ethical considerations is paramount. This involves addressing authorship and ownership issues related to AI-generated content, ensuring that creators are appropriately recognized and compensated. It also includes ensuring fairness and avoiding biases in creative outputs, promoting diversity and inclusivity. Enhancement of evaluation techniques is needed to refine how we assess AI creativity. Combining human-AI collaboration for better assessments can lead to more accurate and meaningful evaluations. Developing standardized benchmarks for AI creativity will facilitate comparisons across different systems and promote progress in the field. Advancements in AI models are crucial. Creating models capable of higher levels of abstraction and innovation will enhance AI's ability to produce truly creative outputs. Incorporating feedback mechanisms, where AI systems learn and refine their creative processes based on human input, can lead to continuous improvement. Cross-disciplinary research will play a significant role. Collaboration between AI researchers, artists, scientists, and ethicists can foster a holistic understanding of AI creativity. Exploring the impact of AI creativity on society and culture will help in navigating the ethical, legal, and social implications of these technologies. By pursuing these future directions, we can cultivate AI systems that not only demonstrate creativity but also do so in ways that are ethical, meaningful, and beneficial to society. The journey of quantifying creativity and novelty in AI is just beginning, and its potential is as vast as human imagination.